Hey friends, so this is a continuation of the Introductions to Conics videos 1. Um, so we were just talking about sort of the definitions and the um, structure of an ellipse. And so now we're going to take a look at the equations of an ellipse. And so we've been looking at an ellipse that's not very good. We were looking at an ellipse that was a horizontally drawn ellipse. And so the equation for that still has this x minus h squared, where h is still the x ordinate of the center, but we're now flattening it a bit. So we're dividing it by the a squared value, and that a value is half of the major axis, right? Remember, we have this major axis across, and the a value is the half of it. Then we're going to add that to the y terms, so the y minus k squared. But we're going to flatten that or stretch it, depending on what the value is, by a b value, and that b value is the minor axis of our ellipse. And that's all equal to 1. Now, if we had a curve, an ellipse that was elongated along the top, those values would change, right? The a value would be vertical, so we'd have the y minus k squared with the a value. And the minor axis then would be a horizontal axis, so that would be the x minus h axis for the minor one, and that would still equal 1. Okay. And then we talked a little bit about this a value and how we can sort of slide it up, right? If we take this a value and slide it up to where the focus, to touch the focus and then lean against this intersection of the b value, the minor axis, and the ellipse. This is my a value. This is the same length. And it's actually kind of fun to play around with that for a little bit. So we'll see if we can really look at that. That's one of the really neat qualities of an ellipse. And we said that we were interested in this distance here between the center and the focus, C. So the distance between the center of the ellipse, which we can find from h comma k, and the focus, we can find using this formula c squared equals a squared minus b squared, remembering that the a value is the hypotenuse. So we would really have a squared equals b squared plus c squared, and then we solve for this c, which is not the hypotenuse in this case. So be a little careful with your just names of it. Okay. One of the things that you'll also see is that you might also see it written in a general form instead of the standard form. So you might also see it written in the form ax squared plus bxy, we're eliminating those for this unit, plus cy squared plus dx plus ey plus f is equal to 0. So that would be the general form. But unlike the circles, the a value and the c value won't be the same, right? In the circles, these were equivalent, which meant that it was proportional, or it had a constant radius. But here, not proportional, excuse me, a constant radius. But here the a and the c values aren't the same, which helps give it that elongated aspect. Okay, so let's go ahead and try an example problem to actually draw an ellipse. So if I take a look at the formula here, the center of this ellipse is going to be at 0, 0, because there's no h or k value here. So here's my center of the ellipse. And the a value, right, we know is the major axis. But a squared, based on our formula, is equal to this number right here. So a squared is equal to 16, and that means that a is equal to 4. We're interested in the positive case here because we're talking about distances. Now be careful, because look at this ellipse. In this ellipse here, we've got I'm actually doing, I apologize, you guys might be a little confused. This is actually the second one in your packet, so please take a moment and find this one. This is the second one in the packet. This one right here is a vertically aligned ellipse because the y is over the a value. So my major axis along the vertical incline is the a is 4. So 1, 2, 3, 4. That will take me to the edge of my vertical, to the edge of my major axis. And then the other direction will also go 4. 1, 2, 3, 4. Right? So my major axis is twice that a value. Okay. Now let's find the b value. So b squared is the secondary number, right, the smaller, is equal to 9. So b is equal to 3. Again, we're interested in the positive case because we're talking distances here. So my minor axis goes 3 on each side of the center to give me my minor axis, which is twice that b value. Okay? And so that's how the a values and b values sort of come into play. Now we need to find the foci. We need to figure out where are the focuses, sorry, where are the foci for this problem. So I'm going to use the rule that we have that c squared is equal to a squared minus b squared. And I've already got my a squared and my b squared values, right? So I've got 16 minus 9 is equal to c squared. And so c is equal to, c squared is equal to 7. And so if I take the square root of both sides, and again, interested in the principal root of that, c is equal to the square root of 7. Which is about, I'm going to estimate it so I can think about graphing it, which is about 2.6. So starting from my center, on the major axis, I'm going to count up 2.6, and that's where one of my foci is, and then 2.6 down is where the other one is. Okay. And so now I can come in and I can actually just sketch out the rest of this ellipse. It's going to connect the major axis to the minor axis, okay, and should be nice and rounded all the way, okay. And I can give the coordinates for these foci, so they're both at the point, this one's at the point 0, positive 2.6, and then this one's at the point 0, negative 2.6. Okay, let's see if we can find that other example, that first one. Where did it go? In my notes somewhere. Oh, maybe I didn't get it copied in. Okay, but we can, I'll just write it here. We'll do it with this graph. So the other example, the first example, if you'll turn back to your first example, was the equation x squared over 25 plus y squared over 16 is equal to 1. And so here we've got, again, the center is at 0, 0. Okay, center is at 0, 0. And we've got an a value here of, so a squared is 25, so our a value is 5. And we've got a b value, b squared is 16, so b is 4. And so my major axis here is oriented to the x now, so it's going to be a horizontal major axis. So 1, 2, 3, 4, 5 to the right of the center, and 1, 2, 3, 4, 5 to the left of the center. Our minor axis is with the y, or the vertical, so it's 1, 2, 3, 4 above, and 1, 2, 3, 4 below. So here's sort of the shape of our ellipse. And we need to find out where the foci are going to be. They're going to be along this major axis, and so we're going to solve for c squared is equal to a squared minus b squared. So c squared will equal 25 minus 16, or 9. And so c is equal to, again, we're thinking of distance, so c is equal to the 3. So along this major axis, 3 in one direction, 3 in the other direction. So my foci here are the points 3, 0 and negative 3, 0. Okay. And then we can sort of connect our ellipse. Missed that one there a little bit to draw it out. Okay. All right, I think there's one more example in your packet that has a different center. Let's see if we can find that one. There we go. So here I'm just going to do one last example. If you think you can try it on your own, do so. Pause me, see if you can do it, and then you can verify. So the center for this ellipse will be 2, comma, negative 2. Remember that the signs for the h and the k are switched. So at 2, negative 2 is my center. And this is oriented along the horizontal, the major axis will be horizontal because it's with the x term. So I'm going to find my a squared, which is 16, so a is 4. So along the horizontal, I'm going to count 4 in each direction. And the b value is, b squared is 4. So I'm going to take the square root of both of those, and so b is 2. Again, I'm interested in the distance, so I'm interested in the positive. So there. And then I'm going to need to find the foci. So c squared is equal to 16 minus 4. So c squared is equal to 12. So the square root of both of those sides, c is equal to 2 root 3. And 2 root 3 is going to round, give us an approximate value of about 3.5. So from the center, I'm going to come out 3.5. 1, 2, 3.5. And from this one, I'm going to come out 3.5. 1, 2, 3.5. And that's going to be my ellipse. I'm going to just find the values of these foci so that we have them. And so this point is at 5.5, negative 2. And this one over here is at negative 1.5, negative 2. So I counted those out, but you could also subtract them from the center or add them to the center in order to get specific values if it were harder to count. Okay, I hope that helps, and I hope that these two videos, I should say, are useful in your review of conics. Thanks.